Just as search engines, browsers, and Google disrupted the internet, and Napster and peer-to-peer file sharing changed the face of the recording industry, Bitcoin and its blockchain technology, plus its associated ecosystem, will eventually force financial organizations to reconsider and change their traditional roles and infrastructure. The blockchain industry and its taxonomy are still in discussion, but its effective power and reach are now, without doubt, a force that will be reaching all areas of tech, finance, and society. And to talk a little bit further on conquering the divided, is blockchain here to stay? I would like to invite our next speaker, Jayavaradhan Sambedu from Société Générale. Jay has over 13 years of experience in the BFSI space and is currently the head of emerging trends and technologies in the innovation department of Société Générale. Jay has been tracking and carrying out POCs on blockchain technology, on the blockchain technology trend with SGGSE for the last year. He is one of SG's representative in the prestigious R3 consortium, and he also runs his own internal startup within SGGSE called Arcis, which focuses on blockchain use cases. He's quite passionate on mentoring developers and startups who focus on emerging trends. Please give a round of applause. I'd like to invite Jay on stage.
Good morning. Okay, Winston Churchill once said, "Never let a good crisis go to waste." Right? At the peak of 2008 financial crisis, something happened which was totally disruptive. There was a white paper that was released by an anonymous source called Satoshi Nakamoto, and that talked about a digital virtual currency which is completely decentralized. Had there not been a subprime crisis, an idea like this would have been just thrown out of the window because it didn't make sense. What is in the interest of banks to do something like this? But that is precisely why, because of all the chaos that was happening around, something like this suddenly made sense. What was this currency? It's now famous, the Bitcoin. What made this so famous was that it was completely virtual and nobody owned it. And in a way, everybody owned the system. How did they manage to do something like this was what was started to be researching, because Bitcoin went through its own journeys, it has its own notorieties, it's associated with a lot of things, and some people don't really buy into the currency because it's highly volatile. At its peak, it went to $13,000, and at its low, it reached as much as $600. So people don't trust that as a currency per se. But what makes it special is the platform that was designed to protect the Bitcoin, and that is the blockchain. What a blockchain does is it manages, in today's terms, about $13 billion worth of Bitcoins. And until now, in this day and age when there are sustained attacks and hackers seem to get through it, the blockchain itself has not been breached. And that says something about it. It's just a 5 MB software that's running on peers, and there are about 8,900 of them. And because there are 8,900 entries of this ledger that are maintained, it makes it extremely difficult for someone to just walk in and hack, just like what you would do with a centralized database. So what was so groundbreaking about blockchain, and why is it so much of a rage right now? There are only 3 essential components to what makes blockchain very unique. These 3, incidentally, are not even something that blockchain did for itself. What it managed to do is bring all these 3 under one umbrella, which makes it really fascinating. The first thing is the cryptographic hash algorithms. It's a class of algorithms which specifically do one purpose. That is, it's unidirectional and you cannot trace back from what was originally created. Now let me explain that a little more in detail. Now let's assume you have a PDF document which is, say, 10,000 pages large. Now digitally, if you were to send it, there are always people who could manipulate it, change it, and do anything they want with it, and there would be no way you would be absolutely certain that the document was not manipulated. So what is the solution? You send the physical document itself to multiple places, and you see in many cases that's what we do. You look at the trade finance world, most of them are physically handed because you don't want that element of trust to be broken. What the secure hash algorithm does is it uses a unique way called a Merkle-Damgard transform. And I'm not going to bore you with the technology around it. In a nutshell, irrespective of what your size of the document is, it can uniquely create a 256 character digital thumbprint of that document. It's quite advanced in the sense that the top secret communication of the US forces and some parts of India as well use SHA to protect their classified communication. It is also a little unique because imagine this, you have a 10,000 page document which is now digitized into a 256 character string, and let's say in the 9,000th page you just changed as much as a full stop and you try to manipulate it and you sent that document out, and if you verified again with SHA, out of the 256 characters, 32 would have changed. So simply put, there is no way for this to be manipulated, and this has been tested and thoroughly tested, and it is battle ready. So that's one of the first aspects of blockchain that is used. It uses a secure hash algorithm. The second aspect of it is the digital signatures. Digital signatures today we are all very common. It's commonly used. We also are comfortable with the public key cryptography, where you have a public key which is open to all, and a private key is what you control, and the owner of a private key has access to the information that it secures. Very similar to how, for example, if someone wanted to reach out to you, it's your interest to broadcast your email ID to everyone, but not your password. So the password helps you log into it, and it proves that you are the individual who's logging into this particular platform. It's similar to that. A public key is just like your email ID, which should be circulated to all. And a private key is your information that you keep it secure, offline, and in many cases as far as away as possible, so that it's easy to do that. Now, the world leader in most of these cryptographic solutions is RSA, as many of you would have known them. So the RSA uses, all cryptographic functions use something called a mathematical trapdoor to make their, to increase the level of security. Now the RSA uses a very simple technique. I call it simple, but when it was done, it was groundbreaking, way back in 1977. The idea is very simple. Computers are extremely good with multiplying two numbers. But once you give the result and you ask a computer to figure out what were the two numbers that gave this result, a computer is going to take more time than what it normally takes. What if you made this number really large and you made it specifically a prime number? Now suddenly you've tricked the system. The system, there are so many only primes, and the primes do not follow a particular pattern. So there is no way for someone to just come in and just guess the value. But if you could, well, you could break into an RSA system. Now till now, RSA was pretty secure because there was simply no challenges that it was facing. But anyone who breaks into a cryptographic system has a lot of incentive, because most of the RSA servers drive the critical infrastructure what we use today. That's exactly where blockchain introduced a new paradigm. It uses something called an ECDSA, which stands for elliptic curve digital signature algorithm. Now, what does ECDSA do? It does not use a simple prime number factoring method. It uses something called elliptic curves. People who are comfortable with mathematics, again, this is a dense level of mathematics involved in this particular topic, but ECC is significantly difficult to break. A simple example is if you were to do a brute force attack on a 32-byte standard RSA, two prime number method. Security companies have done this research, which says if a computer was put full time into cracking using a brute force attack on a 32-byte RSA, it generates some heat, right? The CPU gets heated because it's doing a lot of mathematical operations. Now they've tried to figure out what could you do with that heat. I think that's the easiest way they can explain something to laymen who are not comfortable with security. So apparently with a 32-byte, what heat it gets generated, you could heat a teaspoon of water. That's maximum you can do, which means it doesn't take that much effort for a system to break it. For the same key strength of 32 bytes, were you to use an ECDSA algorithm, the amount of heat generated could simply boil away all the water on planet Earth. And that's just a 32-byte, what we use. And what Bitcoin uses or rather blockchain underpinning it, uses a 256-byte. And from 32 to 256 is not just a multiplication of 4, it's an exponential increase. So it indicates how secure a blockchain's second part is. Again, this is not new to blockchain. Blockchain has managed to bring these two together. And the third most important part is the consensus. For example, you're today at the NPC event, and let's say you liked the post on Facebook, and tomorrow you traveled to Singapore, and you wanted to check your Facebook status. It should still indicate that you liked the post when you were in Bangalore. Is it the same data center that is serving you? Definitely not. The data center in Singapore, or whatever is the closest data center there, and a data center which was closest and proximity towards Bangalore, both of them should have shared the information between them so that you, as the end user, have a seamless experience wherever you went. Imagine if the information was not shared between these two entities. We are looking at chaos, and there simply cannot be one centralized infrastructure that could solve this problem. That was the third bit of interesting thing what blockchain did. It introduced a P2P model, which means any transaction that is broadcast on the blockchain network is simultaneously broadcast to all the peers. So simply put, there is no incentive for any hacker to log in and just hack into one particular node. That means nothing. And since a blockchain maintains an unbroken link from the beginning to the end, anyone who tries to manipulate one block in a blockchain not only has to manipulate that, he also has to manipulate the previous block, because the previous block's reference is maintained in this block. So on and so forth, that even if you wanted to make a single entry in somewhere down the corner, you will have to change all the records until the first block. And simply put, it doesn't make sense, because none of the others would agree with what information you're broadcasting to it. So these are the three important elements of a blockchain, and that's what makes it interesting, because it has clubbed all these three under one window. And today we have various classes of blockchains that are available. You have the completely private blockchains, examples like multi-chain, through which you can run within your own labs or within your own organization. For example, to maintain your referential data, you could do things like that. You could go into semi-private blockchains, mostly in the world of Ethereum, Hyperledger, in that mode. And then you have fully private blockchains as well, which are again, and fully public blockchains like the Bitcoin system, which practically everyone's now aware of. And as Alfred Wainwright once said, there is no such thing as bad weather. Only thing are unsuitable clothing. You know, in many cases, sometimes in our complex world and requirements, the standard way in which we were doing things are no longer possible. And blockchain today presents an opportunity for you to redefine and relook at some of the business models what you've been having traditionally. So let me just give you a few updates on what many startups are trying to do in the blockchain space. So developers always have this feeling, mostly freelance developers always feel that they don't get their fair share of profits when something becomes a big success. Imagine the guy who actually developed the page ranking algorithm. If he was a freelancer, there is no way he is going to stand to get a windfall. Maybe his promotions and hikes, but not a windfall as what Google today relies on. What if freelancers wanted to submit their code and they were completely assured that the payment would be done based on whoever uses that code? Now, blockchain provides that option. And there is a company called Assembly which is doing exactly that. Assembly allows any developer to submit the code, and you trade with something called app coins that are allocated to you. These app coins can be converted to real fiat currency. You have companies like Symbiont who are trying to introduce the entire digital, how to trade, digital security trading space. So Symbiont's platform is also called Assembly, incidentally, and they are claiming that their capability is about 87,000 seconds, transactions that can be done in 1 second. Now the standard Bitcoin can do about 10. So we are talking about a scale which is extremely vast. So that makes NASDAQ very interested in something like Symbiont, what is happening in this space. You have companies like Lazuz. Has anyone heard of it? Lazuz. So the Lazuz is a ride-sharing app, but it's much different from your Uber or Lyft. So Uber and Lyft, even though they disintermediate the market, there is still a problem that they are the ones who are centralizing the information. They know where you are, they know where the cab driver is, and they try to make a match, and they earn their money out of it. But what Lazuz is trying to do, it's disrupting even that the drivers can now put themselves in control. And a driver can broadcast where he is, and along the way, if you're traveling, if you are a Lazuz subscriber, you can get in. This has a lot more chance of working out than you having to wait for a cab and try that. So that's again another interesting area where blockchain is helping. You have companies like Storj, which are totally into cloud-based storage. In fact, they're much better because they're using a blockchain-based one. When Dropbox came in, it was revolutionary for the kind of volumes it was providing. For 100 GB of data, which otherwise in a standard mode of storage, you were spending thousands of dollars, Dropbox came with this revolutionary $99 for 100 GB. Now Storj is invading the very space using a blockchain tech, and for 100 GB, their charges are about $1.04. So you can look at a 100x reduction because, again, they're using a P2P, and computers which you don't use full time can be made a part of that grid, and they in turn start storing devices on your. You have records industry. I mean, you have Rudimental. It's a very famous, not a famous, it was a band. So Rudimental is also a blockchain-based solution that is available now for artists. So any artist who wants to put up his soundtrack can go and commit it on Rudimental, and direct payments for exactly the loyalty can be done to him without the record labels eating away a huge share of the pie. You have companies like Filament, which are trying to work out how IoT can work with blockchain. And in the world of increasing IoTs that are coming in, a blockchain will fall a lot of a crucial role. So I can go on and on and on. There are quite a lot of startups that are working in this space. I only wanted to give you a small brief of what all these can do. Now, what blockchain is also doing is a little more interesting. Right? Traditional competing banks, for example, 74 of the banks have joined one consortium called R3, and they're trying to figure out how to collaborate with each other. This was never happening before. No technology change has ever resulted in 74 competing banks coming together to just explore how to make, because everyone's bleeding, and at least coming together, we could reduce that, is the kind of thoughts that are coming in. So slowly and steadily, what blockchain is trying to do, it's ending up conquering all the folks who are divided. They could have been divided by banks, they could have been divided by ideologies, but blockchain is bringing them all under one umbrella. And to answer the question, is blockchain here to stay? An emphatic answer is yes. Thank you.
Thank you, Jayavaradhan. That was